All right, this is our introductory video to Chapter 5, but in a way, we've previewed some of Chapter 5 in Homework 0. So the introduction to Chapter 5 has already been made. And actually, I want to say, in a very real way, you have been preparing for Chapter 5 since 4th grade. And it might be a bold claim, but how do I mean that? Well, I have this grade school problem right here. Now, this does come up, but that's not why I'm bringing it up. You might have a fraction in this chapter where you have 14 divided by, or 14 over 21. And notice what I did. I noticed that 7 is the common factor. In other words, I could divide both 14 and 21 by 7. The 7 is invisible, so it is a frustration to most students when they're first learning this. But once you realize that 7 is a number that I can divide both of these by, we go ahead and do that, and we get the right answer, 2/3. All right. Well, I'm going to say let's change the way we think about that. And the reason why we have to change our thinking is division's not really available to us when we're talking about algebra problems. Because in an algebra problem, these won't be numbers, they'll be polynomials. So with polynomials, we've done it in the previous chapter, dividing polynomials, but it's a lot of work with synthetic division or long division. All right, so not division. What am I going to do? Well, I'm going to factor, and that's exactly what this is called. Factoring 14, it's 2 times 7. Factor 21, it's 3 times 7. And we can cross out the common factor and we get the same answer. And actually, some students, some grade school students actually like this better because, I don't know, 2 weeks, 3 weeks later, they can look at it and they can see the 7 was canceled. And over here, it's still a mystery because the 7's invisible as to maybe what we did there. All right, but I think I've said it several times, but what is the difference between the two methods? Well, in arithmetic, we often rely on division. We don't have to. We could rely on factoring. This is a perfectly valid way, but we rely on division. But in algebra, we rely on factoring. So let's do a few more problems to connect the idea of arithmetic and algebra. So I have them written here. Don't need to copy them yet. Hold on. All right, I'm going to add fractions probably in a way you haven't done before. And I don't know, when was the last time you added fractions? It might have been a long time. So you might not remember exactly how you tackle a problem like this. But what I'm saying is the best way to think about it is to use factoring. So 14 is 7 times, or 2 times 7. The 21 is 3 times 7. Now, let me go through this reasoning here in a fun way. Okay, well, I think math is fun sometimes. All right, in a fun way. All right, after I factor, I want you to think this way. This denominator is jealous of his neighbor, and this denominator is jealous of his neighbor. So why? Why is 2 times 7 jealous of 3 times 7? Well, 2 times 7 doesn't have a 3. So he's going to go out and get one. All right. 3 times 7 is jealous of 2 times 7. Why? Because 3 times 7 doesn't have a 2. He's going to go out and get one. So that's exactly what we did. The 2 times 7, now it has a 3, but I had to put a 3 in the top and the bottom because I want to keep it equal to what I had before. So whatever change you make to the bottom, you have to make to the top. But same thing here. This 3 times 7 didn't have a 2, goes out and gets one. And now, notice the denominators are the same. I mean, they're in a different order, but they have a 2, a 3, and a 7. So I have a common denominator, 2 times 3 times 7. Numerators, I'm just going to add those together. And I get, well, falling off the page here. I get 7, 2 times 3 times over 2 times 3 times 7. Notice I kept the 2 times 3 times 7 factored. I didn't multiply it out. Probably a good idea when you're dealing with polynomials. But it was even a good idea here. Notice how the 7 canceled. Anyhow, I get 1/6 as the final answer. So that's the correct answer to adding these fractions together. All right. So how does that teach us something today in chapter 5? There's my question. I'm going to add these together. The only thing available to us is factoring. So factor. And what did I say about this? Once you factor the denominators, they get jealous. Y is x plus 4, x minus 2, jealous of this expression here. Doesn't have an x minus 4. Why is this one jealous of its neighbor? Doesn't have an x plus 2. Goes out and gets them. So we go out and get the thing that's missing, like a genuine jealous neighbor. And that gave us the numerator before the plus sign, the numerator after the plus sign. I just wrote that down here. And it gave us a common denominator, which was the whole point of that jealous denominator and getting the same thing. I have to just go through order of operations here and combine like terms. And all right, so I put a check mark here because this is the right answer. But we don't know it yet. In other words, does this reduce? Can I simplify this? I have to go through the process of factoring the numerator just in case this problem reduced in some way. But there are no common factors in the numerator denominator. So since it didn't reduce, this is one of those situations. Since it didn't reduce, an earlier answer would have been fine. I guess the point is you don't have to have the numerator factored or the denominator factored to have the right answer. And let's look over here. It's kind of like saying 1/6 is fine, but 1/2 times 3 is also fine, at least if you were talking about algebra, because there's nothing wrong with leaving an answer factored. In fact, I think it would be almost crazy to not leave this factored. You'd have to multiply this all out to get some polynomial that would start with x cubed. No, we're not going to do that. So leave things factored, leave them unfactored at your convenience. The website will give you the correct answer, whether it's factored or not factored. All right, so that was, well, adding rational expressions. I have this example of dividing, and let's kind of review the idea of dividing fractions. Again, like I said, you've been preparing for this day for a very long time. How did you divide fractions? Well, I hear you saying it. Multiply by the reciprocal. So I'm changing times 2/21, or sorry, divided by 2/21 to times 2/21. And that gives me, after I factor, it gives me this. Now, one thing you might notice I did, this is a times, and so is that multiplication. But I put that little X in there to remind you of something. I'm doing something that's extremely rare in the fraction world, and that is what a lot of students call cross-canceling. Books don't seem to like to use the word canceling, but I think everybody knows what I mean when I say cross-canceling. What am I saying? I'm canceling not within one fraction, but two different fractions, but I'm canceling on the bottom of one across this multiplication symbol to this one. The point I want to make is that only works for multiplication. For example, way back up here, I couldn't cross cancel this 14 and that 2. That's not multiplication. So the symbol kind of suggests that I can cancel this way and cancel this way. All right. So that's why I use that symbol when I'm about to cross cancel for the first time. All right. After you cancel the 7s, you multiply everything together, and we get 9 over 4. All right. So that's how you may or may not have factored or added fractions all your life. All right. To say you've added fractions all your life, I mean, you've done it. Or I'm not saying that. Divided. You divided fractions. You've done it. You just might not remember doing it. But all right. Now let's look at this problem. Here we are dividing fractions. Yeah, we don't have a 3 in the numerator. We have this whole polynomial in the numerator. But you know what? We're going to treat it as similarly as we can to the problem I just went over. Including noticing that I have a division. That's what this middle line here is. And then I'm going to change to a multiplication. So let's do that first. To divide, we multiply by the reciprocal. So the reciprocal is just, instead of the x cubed plus 8 in the numerator, it's going to be in the denominator. What did I do? Well, kind of what you knew I was going to do, factored. So I had to factor this. So each one of these factor, and I think I might have mentioned this back when we were reviewing factoring way at the beginning of the semester, that one problem might have 4 things to factor. And you just have to do what do the factoring. Nobody's looking for how you're doing it at this point. In other words, it's not a show your work kind of thing. Just go ahead and factor. And that's what I did. I factored all 4 of these, including this sum of cubes. That's a factorization that we learned in chapter 4. All right, so the whole thing's factored, and now what? Well, you know what's coming because I used that symbol. I'm going to cross cancel. Not all of these are cross cancels, but most of them are. This is x plus 2, and I cancel an x plus 2. There's a 2 here, I cancel the 2. There's even an x and an x squared, so get rid of one of the x's on each. This is not a cross cancel because they're on the same fraction. Cross cancel means across the symbol. So this is just a regular cancellation or reducing a fraction. But I have identical factors, so those cancel. So do you see what survived? Just in the numerator, x minus 6. In the denominator, one of the x's from the x squared and the x minus 3. So that is dividing fractions, rational expressions, fractions made up of polynomials. All right, so this is your introduction to Chapter 5. I'm uploading some of the author's videos from Chapter 5, but I want you to kind of keep in mind that this is not something you haven't seen before. You've seen adding, subtracting, multiplying, dividing of fractions with numbers in them. And that's what I mean by you have been preparing for this moment since you first added some fractions or even reduced a fraction. All right, take a look at the other videos, and I'll do one more video in Chapter 5 that kind of summarizes where we've been, but this is my introductory video for Chapter 5.